are graphing rational functions. And rational functions, if you remember, they are algebra fractions. We're graphing fractions. And if you remember yesterday, we did a problem and we said, oh, that's a bad answer. And when we have bad answers on graphs, they go a little crazy. They get a little psycho. So these are some graphs that are nearly impossible to do with a T-chart, right? We can't use the fallback method of, well, I'll just plug in the points, because it kind of doesn't work, right? You would have to plug in so many points to get the right shape for this graph. You're going to just watch me for a minute, because I am actually going to do it for a hot minute and show you why this would be bad, right? So here's what I got: X, I got Y, I plug in 1, I get 1, and you're like, Miss T, light work, why are you being such a weirdo baby? Ew, watch what happens on 2. I am right away heading to fractions. So now I'm here, I plug in 3, oh, I got more fractions right on here. So here's what starts happening. They start getting really weird and really crazy. And it's really tempting to see the 3 and feel like, okay, well, Miss T, can't I just sketch it from there? And it will give you the wrong answer, because I'm going to show you what the graph really looks like. The graph really looks like this, and it really comes down and looks like this. And that's not all. It also looks like this, and it comes down and looks like this. And it would be very, very challenging to plug in enough points to get the correct shape of it. And as a matter of fact, there's some weird parts on this graph. This graph is going to get closer and closer and closer and closer to 0. And I could plug in 1,000,000, and I'm going to get 1 over 1,000,000, and I'm going to be 1 atom away. But I will never, ever, ever touch this line, ever, ever, ever. And in math, there's a word for that when we don't touch a line. Do you remember that from last year? Asymptote. There you go. And it turns out we're going to have a bunch of these in the next few days, because even on this one, we don't have 1 asymptote. We have 2 asymptotes. And so here's the deal. Our job, the way that we're going to do this much easier, is instead of plugging in points, we're going to get all the boundaries. So imagine I have a room. I'm in an action film, and I'm trying to run away, and there's lava blocking me that way, and there's lava blocking me this way, and there's alligators blocking me this way, and I have to jump over a pit. I could figure out my path by like avoiding the lava and avoiding the alligator pit. That's what we're going to do. We're going to learn all of the things that block our line in, and finally on Friday, once we know where all of the barriers are, we're just going to come in here and sketch the graph very, very easily. But before we do that, we need to know all of the parts to a rational function graph. Are you guys with me? Everybody okay? Okay, so here we go. We're ready to start. Key features of a rational function. So the first thing I need you to do is I need you to write this down, especially for my sweet, sweet potatoes who are going to be taking a math class next year that is above this one. Maybe you're taking college level pre-calculus. Maybe you're going straight to calc. What it really looks like is this crazy thing. P of x over Q of x. And you're like, what the hell does that mean? What that means is you're going to have a little baby algebra up here and a little bit of baby algebra down there. If you don't have letters in the denominator, you don't have a rational function. You just graph it like we did with the little roller coaster things on the last chapter. But they will have variables in the top and variables in the bottom. Are you cool with that? There are 5 barriers or 5 key points that we're going to look for. We're going to list them all right here. We're going to find them on our graph in a few minutes. And tonight, we're going to learn how to find 3 out of the 5. Tomorrow, we'll find the other 2. And on Friday, we'll put it all together. So here we go. The first key feature of all of these, and I round out a room. So 1, 2, 3, 4, 5. These guys sometimes will have what we call a vertical asymptote. And you know me, Mrs. Tarantino does not refer to that one like that. I refer to this as a lava wall, because what you have is lava dripping down the side of a cliff. It's coming vertically down, and if you were trying to leave this room and there was lava dripping down the wall, you would not go that way, right? You're going to stay away from lava walls. Lava walls are bad. The next thing that they might have are horizontal asymptotes. And you know what that is? That's lava on the floor. This is the game you played when you were a little kid with your brothers and sisters, where you tried to go from one area of your house to another without touching the floor, because the floor was lava. Or maybe you did it on a playground. It was like, lava, there's lava. And you had to like walk on all the, I know you did it. I did it. Everyone played floor with lava. So that's when we got lava on the floor. And that means we're not going down any further because there's lava on the floor. Sometimes we can even have lava on the ceiling above us. And we are going to be like, oh, get out, because the lava is going to crash on us. The next thing that these guys have sometimes are x-intercepts. And they will look like this. Something, comma, 0. That's what they're going to look like. Right? Oh, and let me go back to this. This will look like x equals something and y equals something. There you go. It's a point. And it's a point on the x-axis. And it's really easy. And it's always going to be a number, comma, 0. A lot of kids say, well, Miss T, what about a y-intercept? And we don't find them on these because that takes some work. And on this, these are really easy to find. That's why we like these, because you're going to be like, oh, Miss T, those are easy to find. And I'm like, you're right. So they're not that hard to graph. The fourth thing that we might have is my favorite thing. And I don't know if you know this. This is true. If on occasion, on rare occasions, you can actually get close to lava on the Big Island, right? Normally what they do is they super block it off when there's a lava flow. And sometimes they'll go through this weird neighborhood. There were these new houses and they're in the lava field. But people are idiots because they get kind of close to it, and everyone thinks I'm just going to touch it. Everyone thinks I'm just going to touch the lava. And do you know what happens if you touch the lava with your finger? Do you know what happens to your finger? Yeah, it doesn't get burned. It just comes off. Like if you put your finger in lava, you don't come away with a burned finger. You come away with no finger. Like, so whatever you dip in the lava and you pull out is gone, because it is like, you know, it's melting rock. It melts your finger off, right? So that it's molten rock. Even if you do it quick, if it touches it, it will melt that piece off. It's that hot. Yeah, it's not like a fire. I think it cauterizes. Yeah. Well, you know, just excruciating pain of a part of your body being melted off. Yeah, that's all. And as a matter of fact, it's very hard to get close to it. A lava flow, because till you get closer to it, the ground around it is so superheated. Often it will start to melt your shoes before you get close enough. But here we go. I know it's so, I love it, so fun to talk about. I want you to imagine this, though. You're walking in Hawaii, Mount, whatever it is, blows, Mauna Kea, blows a little bit, and a plop of lava lands right next to you. Here's what you would do if you're not an idiot. You see it land, you would go, la, 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 and you'd go around it. You would go around it. And you know what? That's going to happen on these graphs. They're a little, I'm going to call it, you know, Mrs. Tarantino, a puddle of lava. But what it's really called in math is a hole. And some of these graphs are literally going to have a hole. I'm going to show you what it's going to look like. It will look like that. It's a puddle of lava where your graph is like, that's a pit of alligators. I'm going around it, right? It's a hole. So some of them will have holes. The last thing that's going to happen, we are going to sometimes tomorrow need a tiny bit of baby math because sometimes we might need a helping point or two, right? Sometimes we don't have quite enough information that we might need one or two helping points. Usually never more than two, but sometimes one or two, right? Sometimes. Sometimes we don't need any. It's great. It's like, choo, done. Right? Did you show some of this? So here we go. First thing I want you all to do, my lamps, get your highlighter out. So excited. Okay. What I want you to do is I would like you on this graph to see, if you can see, there is a hidden lava line dripping down the wall here. There is one line on this graph that neither of these graphs will touch. It goes up and down. See if you can see it. If you see it, use your highlighter to draw it in. It is up and down, and you will see if you can see it. They both get kind of close to it, but neither will touch it. See if you can see it on your graph. Love that. Love that. Perfect. Do you see it? Here it is. Here it is. Right there. That is our vertical asymptote. So the first thing we need to know is how to put this on our key. And the way we do it, it is hitting, get your little highlighter out. Please put a little heart. This is a heartbreak problem. It's a little tiny heart. And the little tiny heart is at the X line. So we will say X equals 3. Can I just write 3 down? David's watching me. Can I write 3 down? No, because it's a line. I need you to write X equals 3. 3 is just a number, but X equals 3 is an up and down line. Are we good? With your neighbors, change pen colors. Find the horizontal asymptote. Draw it in. See if you can find the horizontal one that they both get close to, but neither one touches. Is that a bad thing? Here he is. Here he is. Put your little heart on the y-axis. Just to let you know that that's how you write the equation. I taught it in the beginning of the year as a heartbreak problem because everyone gets confused. Do I write it as X equals or Y equals? And the way I teach it is you see what axis it crosses. If it crosses the y-axis, the answer is Y equals 1. Okay, next step. Let's find, you can use either your pencil if you ever want to switch again. Let's find the x-intercept. Find that x-intercept. Where does it hit the x line? Where does it hit the x line? It's a point. It's a single point. Yeah, we're going to get there. So our x-intercept, -2, 0. Here's what. You can't put -2. Don't do it. That's not a point. We're not in algebra anymore. You want the x-intercept, you give me the point, -2, 0. Will it always be 0? Yeah, it will. One last thing is my favorite one. You don't have a red pen, but I do. And that is our puddle of lava. Here he is. Here's our hole. And our hole is a point. It's a point of 2, -4. Okay. Can you sweet potatoes. Do the next one on your own. Label your parts. Negative 2 comma 4. Or is it 2 comma 8? Okay, you're doing this next one. Find your parts. Hey, sometimes there's missing stuff. That's okay. There's no x-intercept on this one. It doesn't cross the x line. That's okay. That's okay. And this, on this one, there's no x-intercept. Here I go. I know, did you see that? It did. What'd you do? Will, are we good? Are we good? Everyone good? Okay, pencils down, erase it down, everything down for a minute. On the next one, Jillian's watching me. I don't need you to do the next one, I'm just gonna talk about it. Sometimes we have none. None is fair. But sometimes we have more than one, and that's okay too. So on this one, we're not gonna do it, but watch this. I have a vertical asymptote here that is at x equals, see, it still hates me, -2. You know what it is? It's the highlighter. It doesn't like my highlighter. I'm stopping. I give up. And I have one right here at x equals +2. Am I allowed to have more than one? Yeah, I am. I can have one there, and I can have one there. Same with the intercepts on this one. I've got 1, 2, 3 of them. I have one at -3, 0, 0, 0, and 3, 0. So I just don't want you to think when you hit a problem like, oh, it just had one, I'm done. No, it might have more. And it sometimes on this one, look, it's got no horizontal asymptotes, none. And nowhere where is any holes. I hate when it has no holes. I love holes. They make me very happy. So I want you to understand, sometimes you can have one, sometimes you can have more than one, sometimes you can have none. Are we good? So now we know the vocabulary. Now our job is to figure them out on our own without the drawing. So turn your paper over. I need you to be super clear, and especially if you have a friend like our friend Ben and Natalie who's absent. This next piece is the recipe. And I've broken it down for you as clearly as I can, so I need you to keep this piece of paper for literally the next week because you're going to need it, right? So let's do it all without a drawing because then we're going to be able to make the drawing. So the first thing I need you to do on all of these, step 1, we do not like it written this way. Yeah, we like factor form. So with your neighbors, together, with your friend next to you, I would like you to do this for me. I would like you to write something over something and stop. Factor form, your X factoring, everyone, this is algebra 1, no one should have problems with this. Factors of 3 that subtract to be 2. 3 and 1, Factors of 2 that add up to be 3.
I think you should suggest to just tell us the number.
That's right. I hear you whispering something to me, yes? Of course. You never have to ask. If the path is there, just say. Okay. You ready? Is everybody with me? Have I lost anybody so far? Okay. Next thing I need you to do is to use your pencil or someone's pencil and very lightly cross off the husband and wife pair. That could cancel, but do it lightly. And you're like, what the heck do you mean by that? I'm going to show you what I mean by that. Look at this guy. Look at this guy. But do it lightly because we have to come back to him later, right? So we're not going to erase him. We're not going to get rid of him. So here's what we are working with at this point. We are working with x minus 3 over x plus 2. Have I lost anybody to there? That's almost all the math that we have to do. That's almost it. The rest of it is so baby math. Okay, now this is why we have the highlighters. Highlighters at the ready. Here we go. The first thing that we're going to figure out is the x-intercept. Please use your highlighter, whatever color you have right now. Highlight this word, x-intercept. Like literally, highlight this. Highlight the word numerator. If you even want to go one more step and make a giant N, it is smart to do. The reason I'm telling you it's smart is because I do this every year for the last 30 years. Do I have to relook it up every year? Yes, because it's very hard to remember. So the way we get the x-intercept, here's how easy it is. We know the x-intercept is going to be something comma 0. We just need to figure out what goes there and watch how easy it is. Get your little highlighter out one more time. Highlight this. It's the numerator. All we're going to do is this. X minus 3 equals 0. X equals 3. Boom. You just found the x-intercept. Done. Done. Some of you are going to get really fast and be like, Christy, can I kind of just do that in my head and just say negative 3 is positive 3? And my answer is, yes, you can. Yep. Step 1 done. Let's now find the vertical asymptote. He is my favorite. This is lava dripping down the wall. Switch pens. Get a new color. So who's ever like switch with someone? Yeah. So you have a new color pen. Jack, you with me? Like.
Yep, he is.
I think we're on the whole of, oh no, okay. Okay, you're with me. Okay, new color. Here's what I need you to highlight. Are you ready? New color, vertical asymptote, denominator. Would I also put a giant D here? I would. And take that same highlighter, go over to this guy. This is why I love this guy. Remember I said it's hard to remember, is he y equals, is he x equals? Now watch how easy it is. I just take x plus 2 equals 0, x equals negative 2, done. When I go to graph it, I will go to the x line. I will go to negative 2. I will make it go up and down, and I have just put in my asymptote. It's that easy. So hopefully right now you realize, Missy, we haven't really done any math. The only place we have to do any baby math is with a hole. So now we're going to find the hole. So here we go. Holes are so dangerous. They are literally pits filled with alligators that they are warning signs both on the top and on the bottom. So looking at our original problem, do I have a husband and wife pair that is both on the top and on the bottom? X plus 1, guess what? That's where our hole is. Our hole is there. So here's what we do. If you got a third color of your, if you can switch it, that's awesome. If you don't, that's okay. We are going to find the hole, and it is, and here's what I write. I write numerator and denominator. And so I'm going to come over here, and I'm going to highlight this guy. See why I did it lightly? Oh, come back. And I know I got too fancy. I know, I would just highlight.
No, I was.
Okay. So just shut up and highlight, right? Okay, so here we go. You guys ready? I'm going to highlight it. I'm going to be specific. Okay, so here's what we do. We know it's going to be a point. It's going to be something, comma, something, right? That's what we know. It's a point. The way to get the X value is super easy. We just go to the match or pair and do what we've done so far. X equals -1. So easy. Here comes the only place we have to do a little bit of baby math. To get the Y, we got to take that stupid -1 and plug it back in. I'm going to show you to this guy, right? Is it small baby math? It is, but that's how we get our Y. And it's the only math we've had to do really all day. So here's what I'm going to get. I'm going to get -1 minus 3 over -1 plus 2, -4 over 1, or -4. Are there a lot of steps? Yeah, that's why we're taking a couple days to get this all rolling, right? So here's what we're going to do. We're going to try one together, and then I'm going to show you what you're doing tonight to practice. Are you ready? Is everybody cool? Everyone stop, okay? Here we go. Here comes our next problem. Everyone see it on there. Step 1 is Colin putting away his Chromebook. Step 2 is factor the top and factor the bottom. I'm going to be nice to you and give you a little hint that your top is going to look something like this, and your bottom is going to look something like this. Is it Algebra 1 factoring? It is. Will I make it scary? Am I ever going to do rainbow factoring or something really scary? I don't think I do.
The top needs one. Right?
Take out the,
Oh,
you see it? You see it? I gotta keep it. Yeah, he can't disrupt today. I gotta roll because I'm taping. Look at him. He's like, see him like back away like Homer Simpson. Okay. Yeah, I heard that. I heard someone say -2 plus 2. Very nice. Yeah. Colin, I swear, I need you to get through this.
Tell me what you said.
How are we doing? Are we okay on the top? Here comes the bottom. X plus 4, X minus 2. Okay. That was our real first step, except, you know, one of the other kind. Second step, lightly cross off what you don't need. Cross off what cancels lightly. Nice and light, right? So here's what I'm working with. 3 X plus 2 and X plus 4. Okay, that's what I'm working with.
Will we ever take over for like 10?
Yeah, that means there's no hole and it's always sad when that happens. But it works out fine. Sometimes the hole is, sometimes the hole, to be honest, is a pain in the butt because you have to plug back in.
Yeah.
So when the hole doesn't show up, I'm a little sad, but really not really. And it's like, yay, I don't care. Right? Okay, here we go. We are finding our x-intercept. That is on the numerator. So I'm going to take this guy, this guy, set him equal to 0. 3x plus 2 equals 0. Divide by 3, nice and easy. X plus 2 equals 0. X equals -2. So easy. Boom, he's done. I'm going to let you do the vertical asymptote alone because it's the denominator and it's easy. Yes.
If we have a problem that doesn't have any holes, what would that look like in the equation?
It just means that we would have, like if this had been a plus, it means I would have two intercepts and I would have 2 vertical asymptotes.
Sorry.
No, I'm showing you. No holes.
Oh, so if it has 2 vertical asymptotes, then it won't have a hole.
Not necessarily. You'll see, like sometimes it has stuff, sometimes it doesn't, and that's totally okay, right? Oh, did I lose it? There we go. You just get what you get. And sometimes I like a hole, sometimes it's like fine, it doesn't have it. Okay, did you guys get this? Y equals -4. Okay, gentlemen and ladies, big finish. This is the one part where we have to do a little bit of baby math. So I am going to get rid of all the stuff that I've written. Here we go, big finish. Our whole, yeah. Sorry, it is X. Why do I see? I'm careless. I'm rushing now. And thank you for the people on the video. Sorry about that. Okay, I put the wrong. Here's what I'm supposed to do. I'm supposed to say this. X plus 4 equals 0. And then I go X equals -4. And I'm done. And I was lazy. No, it's the Y. It's Y equals. I did. It's actually right. That's why I messed up and put Y by mistake. She caught me already. She slapped me. Let's do the whole. So, Tyler, what do I use to get the whole? What thing do I use up here? Yeah, I used the guys that cancel out. So the first thing I'm going to do is I'm going to do this because we know it's going to be a point. Here we go. I already have it ready. I'm going to say X minus 2 equals 0. X equals 2. Nice and easy. That's not scary. The only thing that's a pain in the ass is to get the Y. This is the only math you have to do, you big babies, is plug it in here. Will it come out pretty small and nice? Yeah, I'm not looking to kick your ass here. Right? So here we go. 3 times 2 plus 2 over 2 plus 4. 12 over 6. Look at that. Boom. Boom. So this is what canceled. X minus 2, X minus 2, right? So I take X minus 2. Get my X.
Because you use the ones that aren't canceled.
Exactly. To plug back in. Because I use the ones that are canceled to plug back in, I'll get 0. Yeah. I did, and I'll show you why. I used -1. Does that make sense? Because those were the guys that crossed out. Perfect, Karen. That's perfect. That was excellent question. Yeah. We're done. Okay. Listen carefully. Whiteboard cancel out. Whiteboard cancel out. Whiteboard cancel out. Write this on your desk. Girls and guys, I am willing to give everyone credit for last night's homework, right? But I need you to do this right. I'm going to tell you exactly the problem. So write this on your desk. You ready? 1, 3, 4, and 5. Now, we did something completely different on Monday and Tuesday. If you think you're going to be ready for this test by not continually practicing those, you are sadly mistaken. Because if you've noticed, we've gone in a fully different direction. So I have put 3 problems on the back. I need you to practice at least one for full credit. My advice is 2, but at least one of these. I will keep putting these on every night because I don't want us to do all this graphing and then on Monday say, hey, remember these? And you're like, holy shit, I don't remember how to do this, right? So don't screw yourself, right? We got one last test before the final. Let's make it a good one. Yeah.
Is this stuff going to be on the test as well?
Yes.
Wait, one report.
I'm
One
just kidding.
report to the back.
I need 1 or 2 of them. You all have them?
Yeah.
You all have, you have some? I see you guys. Who's Robert?
Like on the edge.
All that stuff.
Yeah.
There's nothing cute about it. There's nothing cute about that almost happened to me this morning. It takes forever. It's on the main road here. I get all watch me work. I remember every day when we would go park on like the side of the road, I would always see Mr. Holyoke yeah, he drives the black car. So I would see him every day.
Oh my gosh, I've been taping that whole time. Sorry.